Let's look at temperature. We can't really tell the temperature by feeling things. You can see this if you put your hand in cold water and the other hand in hot water and then switch both of them to the same temperature lukewarm water. Both hands end up at the same temperature, but one feels hot and the other feels cold. Similarly, outside temperature of 40 degrees Fahrenheit feels cold in July, but feels warm in January. So it's hard to sense temperature just by feeling it. What we can tell is when the kinetic energy of the molecule is lowered, we feel cold, and when it increases, we feel warm. But we can actually measure temperature. One way is the expansion of a liquid. Put a liquid in a bulb, heat it, and it will expand, but usually not much. Still, if the expanded liquid is forced up a narrow tube, the height will go up with temperature, so we have a thermometer. The next question is what scale you put on the thermometer. Generally, you pick landmark temperatures, the low 0 and high 100 degrees. In Fahrenheit, the low temperature is the temperature at which salt water freezes. You may be aware that if you put salt on icy sidewalks, it melts, and that salt on ice makes an ice cream maker very cold. Well, that's 0 degrees in Fahrenheit. Fahrenheit then made the high temperature of 100 degrees body temperature, which we know is 98.6, but 100 is close enough. The Celsius scale places 0 at the freezing temperature of water and the boiling temperature of pure water. What I would like you to do is to know the temperature of well-known situations on both scales. So these are listed above. So for example, if I say you have a body temperature of 39 degrees Celsius, you will know you have a fever. And if I say it's 30 degrees Celsius outside, you will know it's a warm summer day. There is also one other scale of interest, the Kelvin scale. It was discovered when the volume of a gas, any gas, like air in a balloon, was seen to shrink as the temperature got colder. And the temperature where the volume became 0 was estimated from the trend in the volume as it shrank. No matter what gas was used, the 0 volume temperature was always estimated to be negative 273 degrees Celsius. This has become known as absolute zero because temperature only occurs when molecules move. And the only way for the volume to go to 0 is if the molecules stopped moving. So negative 273 degrees Celsius is the lowest possible of all temperatures. If there's a lowest possible temperature, then there should be a scale that starts with this lowest temperature. That's the Kelvin scale. Absolute zero is 0 on the Kelvin scale.